Okay, so Patrick is online, Tariq is also, online. I hope that he would be able to listen to me. And the agenda for today's session is that we have already covered the LO1. LO2 was discussed last time. We will review the few of the slides from LO2 and we'll finish the LO3 tonight. So let us. So the organizational aspects of software development means when you think about the aspects related with the organization, then you face the multidisciplinary nature of the software development. In the nature of the software development, here are 7 core ideas for effective software development. So it advises that begin and end with a focus on value. So you focus on value, guide the product in terms of small slices of working software, organize around the work to be done with people who can do it. Yeah. Plan in terms of features, build in terms of features, slice features thinly, build quality in every day. I believe that few of them are clearly understandable, isn't it?
Yeah.
Like build quality in every day, like you should focus on the quality every day. You never forget that the quality is concerned, right? Slice features thinly, like that you don't try to produce the features in a whole, but come up with the chops. Make sense?
Yeah.
Build in terms of features. Yeah, like if there is a software development team, then no matter that if they say I have written thousand of codes, yeah, and they are working well, but you can clearly ask them that what features are available at the moment.
Yeah.
Like that only one is available out of 10, then feature wise it won't be good enough. Yeah. And again, plan in terms of features, that what features need to be implemented in which sequence and on what priority. Yeah. Then organize around the work to be done with people who can do it, right? So you never organize and plan that the work has to be done by anyone. Yeah, no, that would fail. Yeah, you shouldn't assume that that much work needs to be done in a day. That's not the going to work. However, you need to know that what people, yeah, can do better.
Okay. Yeah.
So that should be the case. It shouldn't be the case. Oh, you have to get it done anyhow, but no, you should only focus on the core skills of the available people and let them do it. It obviously, in normal way, if you have a kind of labor and someone is good at plastering, for example, yeah, and someone is good at flooring, and if you would be mixing up the labor, then they would not do good.
No, that's it. Yeah, my granddad used to be a plasterer.
Is it? Yeah. Good. Yeah. Like nowadays everything is ready made, and everyone can do building, isn't it?
Yeah, a lot of people can. I can do a little bit.
Yeah. And so give the product in terms of small slices of working software. Yeah. Instead of you produce as a whole software, you should incrementally produce the software in slices, yeah, in a working piece. Yeah, okay, this feature, yes, it's working fine, you can test it, you can use it, then keep on working on the slice. That makes sense.
Yeah.
Begin and end with a focus on value. Yeah, so how? when we build a software product, we have some value in mind. Yeah. So if you value not just the money we'll make, but that what we really want from the product, whether that's measured in loss or lives. Yeah. We'll think about what we value and how to get a sense of what's more important and what's not so important at all. Yeah. So basically that's a kind of theoretical, idiomatic terms. Yeah. But the main thing is that you should have some, importance of the software, that at some point you are basically, creating a product, and a product can give you, a life.
Okay.
Make sense?
Yeah. Yeah.
Yeah. Obviously,
Yeah.
uh, like they say, like a work is worship.
Yeah.
You must have heard about it. Yeah.
Yeah. I've heard of that before. Yeah.
So this means, that work like a worship, and a worship is a value.
Yeah.
Okay. So that's it. And I think, the rest of the other things, I explained without going to the slides. Is that okay?
Yeah, that's fine. Yeah.
Okay, good. Now, uh, okay. So we start the LO3. Yeah.
Yeah. Okay. Yeah.
Let's be able to apply a software engineering approach to software and system development. So again, uh, you know, how we need to start, how we need, what we need to do in order to software development. We need to adopt the software engineering approach. Yeah.
Okay. Yeah.
So how? Like project management for software development. So any software development has to be managed. Yeah, has to be managed. The development, whatever you develop, it should be a managed development. Make sense?
Yeah.
However, the development could be, unmanaged. That's possible. That could be, unorganized, and it could be developed in a random way. Yeah. And
Okay. Yeah.
when you want to, so hello.
Hello. I can hear you now.
Okay, yeah. I just realized, that it didn't, complete the, fully utilize the CPU or memory. However, there's a problem in the, maybe, uh, join me, but it's fine. We are back. Yeah.
Yeah. Great.
So develop the software in a manageable way and consider it as a project. Yeah.
Yeah.
The project means you need to have everything in front of you from the starting to the end and their results. Make sense?
Yeah.
Concerned with the activities involved in ensuring that the software is delivered on time and on schedule. Time is means that when it would be ready, and scheduled in a sense that it has been developed according to the target time. Yeah.
Okay. Yeah.
And in accordance with the requirements of the organizations developing and procuring the software. Yeah.
Yeah.
Project management is needed because software development is always subject to uh, budget and schedule constraints. So management would always, be focusing on the schedule and budget.
Yeah.
Obviously, if you have managed, it means you have done everything on time. You are managing. So managing time wise, schedule wise, as well as budget wise. Obviously, for example, if you can, build the software, for example, the expected is a month, yeah, and what's the, solution that the same software you can create in a week? Is there any way to create a software in a week instead of a month? Also, instead of a month, yeah.
Yeah, there is. The way that you could do that is, well, you've got two options. You could either get more resources,
yeah,
or you could possibly get somebody who is maybe more skilled or is faster at working.
like there is a a strong relationship between the budget and the schedule.
Yeah.
Yeah. So you increase the budget, the schedule can be, schedule would be reduced and it could be developed, earlier. If you reduce the budget, it means you reduce the payment for the, staff, and the schedule would be longer.
Yeah.
So key things in the software management, the schedule and budget, they are the most important things.
Yeah. Okay. Yeah.
Okay. So being a manager, these two things, would be in front of you, and everything would be, visible in front of you, that how that project can be managed. And obviously, I mean, that's realistically not only for the software development, but for anything, any development or construction, budget and the schedule really, really matters.
Yeah. Okay.
Isn't it?
Yeah. Yeah. Absolutely. Yeah.
Then project management involves risk management, yeah, managing people and teamwork.
Yeah.
Makes
Okay.
sense?
Yeah. Yeah.
Like risk management is concerned with identifying the risk and drawing up plans to minimize their effect on the project. Most important, yeah. So you always try to implement, yeah, those, components which are difficult to implement, and you think those needs to be done, on priority, and should be done so that you should minimize their effect on overall project. Make sense?
Yeah. Okay. Yeah. Yeah.
Because if you would be trying to do, the easy things first, and you think that the difficult part should be done, in the end, and probably the tricky part can, make you stuck into the, last stage, and you would fail.
Yeah.
Okay. Then managing people. Important role of a manager is to motivate the people working on a project. Motivation means organizing the work and the working environment to encourage people to work effectively. Yeah. So what you will be doing, you every time would be taking care that the coffee and tea, is available. Yeah.
And the biscuits.
And the biscuits, but no sugar. Yeah.
No. Yeah. Okay.
Make sure that no sugar, otherwise, they would feel lazy, and, the sugar is kind of energy.
Yeah. Yeah.
And teamwork, most software engineer is a group activity. Try to get it done in a group. Yeah.
Yeah.
So the development schedule for most significant projects is such that they cannot be completed by one person working alone. Yeah. So it's always teamwork. Yeah. Like, some would be good at, some of these skills, and others would be good at other skills. But if it is given to one person, then the person will be, frustrated and would give up.
Yeah.
Now, success criteria. What are the criteria? Deliver the software to the customer at the agreed time. Most important, criteria.
Yeah.
Yeah, agreed time. Yes, you got it. You done it. You are successful. Yeah. If you didn't, then obviously you are late. You are your reputation is affected.
Yeah.
Overall cost within the budget.
Yeah.
Yeah. So do not try to exceed the budget. Obviously, if you would exceed, then you would be compromising at some stage. Like you would be compromising with something else. For example, uh, you know, you hired a very expensive, developer, yeah, over than the budget. Then obviously, you would be in loss, yeah.
Yeah.
So try to have an overall cost, within the budget. Deliver software that meets the customer expectations. Yeah.
Yeah.
So never try to create a software that customers may meet your expectations, but however you should be able to meet the customer expectations.
Okay. Yeah.
For example, you shouldn't think at any point that okay, particular section of the software is difficult to access, and let the customers uh, try this hard piece. But you should consider that this piece is hard, how you need to make it easier for them.
Yeah. Okay.
Maintain a coherent, consistent, and well functioning development team. Obviously, a serious uh, team would be able to be helpful. If you don't have a coherent and consistent and good team, yeah, then obviously a non-serious team cannot give you success. Can it give you?
No, you'll fail, won't you?
Yeah.
If your team's no good, you'll just fail and you'll look
Yeah.
stupid.
Yeah. So you make sure again that they shouldn't have any problem of the kitchen and these things.
Yeah.
Yeah. Obviously, if they are happy, then they would be consistent and they would be functioning well.
Yeah. Hopefully, yeah. Just say keep them happy. That's the key, I guess.
Yeah. Yeah. Now project planning. So like I said that planning involves break down the work into the parts and assign these to project team members, anticipate problems that might arise and prepare tentative solution to those problems. The project plan, which is created at the start of the project, is used to communicate how the work will be done to the project team and customers and to help assess progress on the project. The project plan should be regularly amended as the project progresses and you know more about the software and its development. So, plan needs to be regularly amended. Yeah,
Yeah.
makes sense.
Yeah. Yeah. Absolutely. Yeah.
Why?
The first plan that you come up with, you're bound to that there's bound to be things that are wrong in it, or you need to change things. It might be that you've got at the start you've not got someone that could do a certain part of it, and then you get somebody in that can do it. In which case you've got to change the plan.
Sorry, can you say again? The project plan needs to be regularly amended. What's the main reason like?
It's mainly so that everybody knows what's happening.
Yeah.
Everybody needs to know what the plan is. If people don't know what the plan is, it's never going to succeed.
No, they know. For example, if they know in advance there's a plan, then
Yeah.
Then because you did a planning, they know the plan, they know about the plan, and why it needs to be regularly amended. Is it a good question?
It's going to, over time it'll change, won't it? That the project will change, so the plan needs to change.
Is it necessary that the project might change?
Yeah, things can change.
Okay. That's the one of the answer, and another answer that's in my mind.
Okay. Yeah.
Basically, when you say the project planning, yeah, it means the planning is always estimated. Yeah.
Right. Okay.
Yeah. When you already know that it is estimated, then there are lots of chances that the planning may need a regular monitoring and amendment.
Okay. Yeah.
Is it good to good answer? Because you should have in mind that planning is always estimated. That's why it needs a regular amendment according to the further progress into the project.
Yeah. Okay. Yeah. I understand.
Yeah. So that's a kind of a daily, like the fire alarm test in a day.
Yeah.
Yeah. So daily, instead of a weekly, like a daily fire alarm, you plan. Is your plan on the schedule, on the right track? Maybe okay. No, amend it. Try to reduce it and give a more emphasize on the different things and reduce the focus on other things. Blah blah. Yeah.
Okay. Yeah.
Project schedule, cost estimate, and risk have to be regularly revised. Yeah.
Yeah.
So the what should be the regular amendments? Those should be the schedule. Like schedule, for example, if you had split that overall progress into 7, slices, then schedule may be amended. Cost estimation may also be estimated in a sense that if you would spend more time on this, then this might cost you more labor. Yeah.
Yeah. Okay. Yeah.
Risks. Yeah. Whatever the risks are, they needs to be considered and revised. There means their monitoring needs to be done. Yeah.
Yeah. Okay. Yeah.
Now there is another topic, like a random topic. Unfortunately, there is no sequence into the uh, learning outcomes and the indicative contents. You remember?
Yeah.
So business process reengineering is basically the act of recreating a core business process with the goal of improving product output, quality, or reducing costs. Yeah. So when you say business process reengineering, it means whatever the process of the business is, you try to recreate it.
Okay.
Yeah. So that process would help you to establish the business as well as the business application.
Okay. Yeah.
Typically, it involves analysis of company workflow, yeah, finding processes that are subpar or inefficient, and figuring out ways to get rid of them or change them. Yeah, so that's just a kind of business terminology, yeah, or in a technical way that you try to recreate the existing business process. And why this has been introduced into the software engineering, probably when you need to implement the flow of information, the workflow. Yeah.
Yeah.
Company workflow means how data travels into the organization or company. That is more important. And for example, if the things are done in a reverse order or in unmanaged order, then your computing cannot proceed. Yeah, your project cannot work in a better sequence.
Okay.
Make sense?
Yeah, that makes sense. Yeah.
Because one input, because one output is received from the another input. Yeah,
Okay. Yeah.
and that output is again the input for the another process. Yeah,
Yeah.
and if you will not prioritize the first process, yeah, then your next processes would be waiting for the previous process, and the system would go into the deadlock.
Yeah. Okay.
Yeah, so try to recreate the company workflows. That is called the business process reengineering, and that business process reengineering would help you to create the system development efficiently.
Okay.
Yeah,
Yeah.
so that's kind of that it doesn't look like that this topic is used within the project planning or management, is it?
Yeah.
Like this doesn't looks like that it is the part of the project management or planning, is it?
No.
No. Okay, so this is a kind of additional thing that you do the business process reengineering. It will help you to give you best possible company workflow. So how you can do this? It has a steps: identify and communicate the need for change, where the things needs to be changed, put together a team of experts, yeah, find the inefficient process and define a key performance indicators. So wherever there is an inefficiency in the process, you should come up with the key performance indicators, that which actions are important and needs to be done first.
Okay.
Re-engineer the processes and compare key performance indicators. Yeah.
Yeah. Okay.
Now, data modeling. You remember that modeling is basically the system modeling. Yeah.
Yeah.
You create the models. Yeah.
Yeah.
Models. You need the model skeleton of the system or anything. Yeah.
Okay. Yeah.
Normally, you create a building according to the model.
Yeah. Okay. Yeah.
You create an aircraft according to the model, isn't it?
Yeah. Yeah. Yeah.
Yeah. So data modeling is a software engineering is the process of creating data model for an information system by applying certain formal techniques. Data modeling is the process used to define and analyze data requirements. So the process which is used in the requirements, that's one.
Okay.
So you represent the requirements according to some model. Yeah.
Yeah.
It has to support a business process within the scope of corresponding information systems in organization. The process of data modeling involves professional data modelers working closely with the business stakeholders as well as potential users of the information system. There are three different types of data models produced while progressing from requirements to actual database to be used for information systems. So modeling can be done at three levels: conceptual level, logical level, and physical level. Can you give any idea about it?
Is the physical layer, is that the way it would be, what people would actually see?
Okay, Conceptual is simply the data requirements are initially recorded as a conceptual data model, which is essentially a set of technology independent specification.
Okay.
Technology independent specification. So they don't know that how the requirements would be presented, used, irrespective of the technology. Yeah. Clear?
Yeah. Okay. Yeah.
Logical
Yeah.
data model is then translated into the logical data model, which documents structure of the data that can be implemented in the database. Implementation of one conceptual data model may require multiple logical data models. So
Okay.
the logical one is, it's again written in the human language. Yeah. That
Okay.
can
Yeah.
easily be converted into program.
Okay. Yeah.
Physical data model, transforming logical data model to a physical data model that organizes data into tables and accounts for access, performance, and storage details. So you really create, for example, a create table in the SQL, and the SQL, for example, would allocate some space for the table for the fields. Yeah.
Yeah. Okay.
So conceptual is independent of technology. Logical is again, not the technological, but it is exactly the structure that can be converted into the physical programming. Yeah. And
Yeah.
make
Okay.
sure that the logical should match the programming. For example, if you are using the object oriented analysis data model, yeah, the
Okay. Yeah.
type of the programming language that you are using should be selected for the logical data model. It
Okay.
shouldn't be the case that you have done the logical data model in an old modeling language, yeah, and you are expecting to implement into the modern programming. Make sense?
Yeah. Okay. Yeah.
Yeah. So that should be the difference between these three. Yeah.
Yeah.
Now, object oriented analysis and design. Yeah. Now we are ready to analyze and design. Yeah. If you remember that, what is the difference between the analysis and design?
The I can't remember now.
Okay. So
It does. No, it doesn't include the. I'm not sure. I'm thinking back to the implementation.
okay, no worries. So
Uh,
if you have a conceptual data model,
yeah.
then you need to create the logical data model. Okay. So logical is kind of analysis and design. Yeah.
Okay.
The analysis is again kind of independent of technology analysis. Yeah.
Right.
And design is basically the implementation specific.
Right. Okay.
Yeah.
Yeah. Okay. Yeah.
So the implementation specific is further converted into the physical design, for example.
Okay. Yeah.
So OOAD is a popular technical approach for analyzing and designing an application system or business by applying object oriented paradigm as well as virtual modeling throughout the development life cycle to foster better stakeholder communication and product quality. Now further in detail, object oriented analysis and design in modern software engineering is best conducted in an iterative and incremental way. Yeah. Now I will read this. The main difference between analysis and other forms of analysis is that by object oriented approach we organize requirements around objects. When you talk about the object-oriented analysis and design, it means your requirements are included into the objects. So you understand what is meant by the object?
Not really. No, what in prog? No, I'm not sure.
Previously, the data, for example, the
Is
any
it like objects in programming when you
yeah,
call?
yeah,
I understand. Yeah.
which integrated both. So when you do the object-oriented analysis, then behavior and data, it's in the object.
Yeah.
However, traditionally the two aspects, data and process, they used to be separate.
Okay.
For example, if you selected an object like a student, yeah,
Yeah.
the student will have the data. For example, student ID, student enrollment number, whatsoever, and its behavior, yeah, would be, our process would be like enroll, exam, like a verbs. A student can do the verbs, actions.
Yeah. Okay. Yeah.
If you are not using the object oriented analysis, then you would be defining separate the attributes and behavior.
Yeah.
Okay, if it is an object oriented, then you would create, let's say, class. Class student, yeah.
Yeah.
So attribute is the name and enroll is the behavior or process. So
Okay.
they, both things are inside the object of the student.
Yeah. Okay.
So that's idea behind the object oriented programming. And the programming itself, for example Java, they allow you to define these attributes like data and processes, which are called the behaviors, into one object. Yeah.
Okay. Yeah.
So key tasks in object-oriented analysis are: find the object, organize the objects, describe how the objects interconnect, define the behavior of the objects, define internals of the object. And common models used in object-oriented analysis are use cases and object models. Yeah. If you
Okay.
remember that we recalled, the UML.
Yep.
Yeah, unified modeling language, and they advise any requirement or scenario into nouns and verbs. Yeah,
Yeah. Yeah.
so the nouns would become the use cases, and the verbs would become the use cases. Yeah, and
Okay.
nouns would become the objects.
Yeah.
Yeah, and obviously the objects would have attributes, and the verbs would be the use cases defined inside.
Okay.
Yeah. Now, design. Yeah. One
Yeah.
second. So, analysis. What you would be doing in the analysis? You would be trying to know the nouns and verbs.
Okay.
Yeah. And
Yeah.
in the design, what you do, developer applies the implementation constraints to conceptual model produced in the object-oriented analysis.
Okay.
Like I said, that you in the analysis, you create those requirements in the form of classes and objects and the use cases. Yeah, they are independent of implementation, but in the design you create according to the implementation point of view, that those needs to be implemented easily into a programming language. That's a design.
Okay.
Yeah. So
Yeah.
that's clear now, that difference between the design and implementation, analysis and design.
Okay.
Yeah, I repeat it again.
Yeah.
Analysis, you find out the objects and use cases, yeah, but you do not define those, take implementation specific model. But after refining the analysis, when you refine the analysis, yeah, you create those, the objects according to the implementation, that how they would be interacted. That would be basically the design, and the design includes more operations. For
Right. Okay.
example, yeah. So the
Yeah.
analysis does not include anything extra. It only includes the objects, yeah,
Yeah.
and the verbs. But the design would explain to you how the implementation would be done and how the interaction would be done among them.
So the design really sort of includes all the bells and whistles.
Like, if you want to write, then analysis only points out, points out or list out the objects and verbs,
Yeah.
and the design exactly, explains how they needs to be implemented and interacted, and what would be their activities.
Yeah. Okay.
Yeah, like, the analysis is the, you select the people, and in the design you would see that how they will play.
Okay. Yeah.
Make sense?
Yeah. Yeah. Yeah.
And obviously what the way they will be playing would be a kind of simulation, and they needs to do a rehearsal, kind of rehearsal, and then they can exactly play into the system again.
Yeah. Okay.
Okay, makes sense now?
Yeah. Yeah.
So the way they would be playing, that's basically the behavior.
Okay.
Yeah, so
Yeah.
they are represented using the behavioral models.
Yeah.
So they show the interaction between the objects to produce some particular system behavior that is specified as a use case. Sequence diagrams or collaboration diagrams in UML are used to model interaction between objects. Right?
Yeah.
So you do the analysis, you list out, find the objects and the use cases, then you define the interaction between the objects. That would be the design, yeah, that are
Yeah.
also called the behavioral models, and those behavioral models in the terminology of UML are sequence diagrams or collaboration diagrams.
Okay.
Yeah, and
Yeah.
I believe that you remember and you have a book of the UML, and you can easily, recall and do further practice on and read on the sequence diagram and the collaboration diagram, and make sure that sequence diagram and the collaboration diagrams would be a kind of, the a kind of play among the objects identified in the analysis.
Yeah.
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 Now, verification and validation. Yeah. In software project management, the software testing, software engineering, verification and validation is the process of checking that the software system meets specifications and that it fulfills its intended purpose. It may also refer to as a software quality control. Yeah. So when you talk about the quality control, you do verify and validate. It's normally responsibility of software testers as a part of the software development lifecycle. In simple words, a software verification means assuming we should build a software A, does our software achieve its goals without any bugs or gaps? Verify
Okay.
means that have you implemented what you wanted to implement? Okay.
Okay. Yeah.
And validation was A what we should have built.
Yeah.
Does A means the high level requirements, means that if whatever you intended to implement it, you verified it, yes, you wanted to make it, for example, you wanted to make it a car, yeah, and whatever the car needs, you put everything into it and you really made a very good car, yeah.
Okay.
But when you try to validate it, then did you realize that whether the car is useful to you or not?
Yeah. Okay.
Probably you needed a train and you needed a line train track instead of the car, because the cars could make you stuck into the traffic, but the train won't.
No. Okay.
So then you need to validate it that yes, it's not only a good software, but it really fulfills all the requirements as well.
Yeah. Okay.
That's called basically the validation. In other simple words, it's also defined as that verification, are we building the product right? Okay. Validation is, are we building the right product?
Okay.
Like, we needed to travel and, whether the car is suitable or not.
Yeah. Okay.
Probably we should have, create a kind of train instead of the car.
Yeah.
Okay. So the objective of verification is to make sure that the product being developed is as per the requirements and design specifications. Validation is the process of evaluating the software at the end of the development process to determine whether the software meets the customer expectations and requirements. Yeah.
Okay. Yeah.
Like the train is good for you, still, the car is good for you, or probably you should have, bring the trains instead of the car.
Yeah.
So there's more on, some on the verification and validation. Yeah. And a kind of, two types of internal verification or validation, internal and external. And internal is like, you assume that goals of the stakeholders were correctly understood. Yeah. And
Okay.
externally validate means that you are performing the task. It happens when it's performed by us, the stakeholders, if the software meets their needs.
Okay. Yeah.
So when you internally validate, then you assume that the for example, requirements were fine, and you try to express, they were expressed in the requirement artifacts and precise and comprehensively. If the software meets the requirement specification, it has been internally validated. Yeah.
Okay. Yeah.
Like, like I said, that validated, for example, someone tried to validate a car. Yeah. A car, is taking you from one city to another city, and it was the purpose. So you say yes, internally it is capable to do.
Okay. Yeah.
And
Yeah.
externally validate, you really ask them that are they happy with them?
Yeah.
The stakeholders will use it. Yeah.
Yeah.
Like
Yeah.
experimentally, when you validate, then it would be the internal validation. Yeah.
Yeah.
By experiment you do, yeah, you calculate, then it's internally validated. And externally, when you ask the stakeholders that if they are happy and they are getting what they wanted.
Okay. Yeah.
So simply, yeah, and don't need to go into the more detail, simply verify that you see if it is done properly as the requirements were, and then in the validation that overall you did your best. Then probably or maybe you might have reinvented the wheel. Yeah.
Yeah.
And
Okay.
whether it was useful or not. Yeah.
Yeah.
So that was the last, topic, and we are done with the software engineering LO3 as well. Yeah, and recall the LO2, and we already finished the LO1. Yeah.
Okay. Yeah.
So any questions so far?
No, not at this point. No, that's all okay.
Okay. Yeah, that's fine. So I end the session now, and we'll start the next session on Monday as proposed, and let's see if you are available and the Tariq or not. We will conduct a cross according to the probability. If anyone is available, then we would record it. Yeah.
Yeah, speak to you on Monday.
Okay, that's fine. Thank you, and thank you, Tariq, for joining. You are still online, I can see, and I will see you next time. Yeah.
Yeah.
All right.
Cheers.
Bye. Thank
Bye.
you.